Okay, now we get to solve an equation. You can use Laplace transforms to solve initial value equations, and in some ways it makes the equations easier because once you get the solution, you don't need to go back and substitute in the initial values. Those initial values are given to you in the definitions for the second derivatives and the first derivatives, and so you're using them right away. You do have to have good algebraic skills. And let's go ahead and try and solve this one. Here, I'm going to substitute into I'm going to apply the Laplace transform to this entire equation. Apply it term by term. So I get the Laplace of my second derivative, and that's given here. Now, where I have this Laplace of y of t, I'm just going to call that capital Y. And so my second derivative, there we go, Laplace of the second derivative is s squared capital Y minus s times y of 0 minus y prime of 0. Okay, and then I have plus 3 times my first derivative. Plus 3 times, and our first derivative is given right here. And again, this Laplace of yt, we'll let that be capital Y. So I get s times capital Y minus y of 0. And then plus 2 times the Laplace of y. The Laplace of y is just capital Y, is equal to 0, and the Laplace of 0 is 0. Okay. Now let's substitute in our initial values. Y of 0 is 1, so this becomes 1. This one becomes 1. And y prime of 0 is 0. So this one is 0, and this drops out. So simplifying, I have s squared y minus s times 1, that's s. This term drops out. Here I get plus 3sy. This is a minus 1, so I get minus 3 plus 2y is equal to 0. So our first step was to take the Laplace of each term of the equation. Write that there. Our next step is going to be to solve for y. Solve for capital Y. And to solve for capital Y, I want to group all these y terms together and factor out the y. I'm going to have s squared plus 3s plus 2 times capital Y. And every other term I want to bring over to the other side. So this negative s coming over to the right side becomes a positive s. Negative 3, bringing that over to the right side, gives you a positive 3. And then to solve for y, you want to divide by s squared plus 3s plus 2. And that gives me my solution for y. Once you solve the equation for y, then your next step is to convert back to apply the inverse transform. Now I'm going to go back to question number 9 because this looks familiar. Yeah, and notice question number 9 is applying the inverse transform to s plus 3 over s squared plus 3s plus 2. And so I'm going to take that y and I'm going to break these this s plus 3 over s squared plus 3s plus 2 up into negative 1 over s plus 2 times 2 over s plus 1 and then I'm going to apply the inverse Laplace to each term. And when you apply the inverse Laplace to each term, this inverse Laplace of y brings you back to y of t. And then that negative 1 pulls out, and the inverse Laplace of 1 over s plus 2 is e to the negative 2t. This 2 comes out. Inverse Laplace of 1 over s plus 1 is e to the negative 1t. And this is the solution to your differential equation.